everyone. Today we are doing the ML assignment, that is the customer spending classification using machine learning, which is guided by Mr. Sheikh Daud Sheikh, Assistant Professor, CSC Department, GM University. These are our teammates. The table of content consists of introduction, dataset description, data pre-processing, model implementation and training, model evaluation, conclusion and justification, challenges and future improvements, and reference. Next, we move to the introduction. In introduction, understanding how customer spends is important for a business. It helps them improving a marketing and many more things. May business want to know how their customers spend money. Why? Because these help them improving marketing, targeting the right peoples. And next, give a personalized offers based on customer type. It can based on customer type. It give a personalized offer, keep customer happy and loyal. And next, in this project, we are going to group the customer into three spending categories. First, low spender, medium spender, and high spender. How to we classify them by looking at age, gender, annual income, and spending score. How much they spend in a month. That is main task. And machine, we are going to machine learning models used in our trained three ML models to make a prediction. We are going to train a three ML model to prediction. First one is K nearest neighbor, that is KNN. It looks at least simpler customers near to decide a category, and decision tree asks questions step by step like a flowchart to decide the category. And Navy base uses probability to predict based on past data. And we are going to use a data set, that is the data in the form of Kaggle small customer data set. It includes the real customer information, which means again age, gender, annual income, and spending scores. It is all about introduction. And next we will move to the dataset description. In the dataset description, we are going to create an SV. We are going to create a one of the file, that is CSV files. Customer small customer CSV file consists of 200 customer record with the following attributes: means a name and a description, customer ID, unique identifier for each customer, gender, male and female, age of the customer, annual income, and spending score. This is mainly targeted with target variable for classification is the spending score category based on low, medium, high. Thank you. Next will be continued by another team.
Hello everyone, I am Junaid. I am going to explain the data pre-processing. Before training machine learning models, we need to prepare the data so that the models can understand and use it properly. Here I will tell you how it is done. Loading and inspection. First we loaded the data and looked at it to understand what kind of information it contains, like which columns are there, which types of values they have, and if there are any missing or strange values. Next is about feature selection. We picked the most useful columns that can help the predicting outcomes. These included gender, age, income, and spending score. Encoding categorical data. The gender column is a word that is male or female, but models work with numbers. So we convert the gender into binary numbers, that is male is considered as 1 and female is considered as 0. Spending categorical creation. The spending score is a number, but we turned it into categories into low, medium, and high. This makes it easier to classify customers into spending groups. Normalization and splitting. Normalization. We scale the data so that All values like income and age are on a similar range. This helps some models perform better. Splitting. We divided the data into training set and testing set, where the training set is 80% that is used to teach the model and testing set is 20% used to check how well the model performs. Next, here we comes to model implementation and training. We use the three machine learning models to learn from the data and make predictions. KNN, that is K nearest neighbors. This model finds the closest data points near neighbors to a new point and checks how they are labeled. It then assigns the most common label among those neighbors to the new point. It can give good results, but you have to carefully choose how many neighbors to consider. A decision tree. This model asks a series of yes or no questions to split the data. Example, if the income is above 50, is age less than 30. It is like a flowchart and is easy to understand and visualize. Navy basis. This is simple model like age and income are independent, which may not always be true. It's fast and good for quick predictions, but the assumption can affect accuracy. Thank you.
Mm. Hello everyone, I am Kadar Goswami. I am explaining the next part, that is model evaluation. Here we use the following metrics to evaluate how well each model performed in our task. So we make use of the accuracy, precision, recall, and FN score. Here accuracy predicts how many predictions were correct overall in the task, and the precision of all the predicted results, how many were actually right, and in the recall, how well the model found all correct results will be evaluated. In FN score, a balanced average between the precision and recall will be evaluated. Coming to the performance comparison between these three models, that is KNN, decision tree, near bias, we came to conclude that the decision tree is performed better than these two models, that is KNN and near bias. That the decision tree gives us the accuracy 88%, precision 0.89, recall 0.88, and FN score as 0.88. Coming to the insights, so after analyzing the results of these three classification models, we observed the following key findings as here the decision tree performed the best among these three classification models. So why the decision tree performed the best? Because it clearly grouped customers based on the patterns like age and income, and it is very easy to explain and visualize, which will help in making the business decisions effectively. And here the KNN give decent results because its performance mainly depends on how many neighbors we choose in the task, and it's slower on the larger data, but it can be fine tuned for the better results. And here the neo bias struggled a bit in this task because it assumes the futures work independently, which always not need not be true. However, it is very fast and it can be useful for the simple or the large data sets. So this is all about the insights. Coming to the conclusion and the justification. So based on the evaluation results above, we came to conclude that the decision tree classifier is the best model for this task. So why we consider that decision tree is best model? Because it finds the pattern easily. Here the decision tree can detect complex relationships in the data like how age and income features came together by affecting the spending in the customers, and there is a no need to scale the data unlike the KNN. And it is very easy to understand that the model is like a flowchart here. So the businesses can follow the steps easily and clearly see why a customer was classified as low, medium, or high spender. Why we do not choose the KNN model? Because it gives the decent performance. Because here the KNN give good results, but it mainly depends heavily on choosing the right number of the neighbors more of the time, and it is slower with the more data. For the larger data sets, the KNN becomes very slow because it checks all the existing data every time. That
घोष नवे से स्टार्ट कर बे ये पीछे से केएनएन से
क्या हुआ?
डिस्टरबेंस बहुत हो रहा है हम बात कर रहे सभी सुन आ रहा सचिन स्टार्ट
हाँ,
कर जल्दी
बी कहाँ से
केएनएन
करो?
से स्टार्ट कर
हाँ बे भाई, आवाज ही चाह रहा सब जगह, कहाँ बैठना मैं? जय बाबा रे। Here, the Canon model performs very low because compared to the other two models, because it gives the decent performance. Here, the Canon give good results, and it mainly depends on heavily on the choosing the right number of the neighbors most of the time, and slower with the more data. For large data set, the Canon becomes very slow because it checks all the existing data each and every time whenever it has to be make a prediction, and it can be improved in the future with some fine tuning and better search methods like KD tree. Useful for us. So why we are not using the new bias and it didn't work for this task is it gives the wrong assumption. It assumes that all the data is correct. It can be useful in some cases that even though it had a very low accuracy score, a new bias is very fast and it can be work very well in other simpler or the large data sets in the future. Thank you.
Hello everyone, I am Arume Sania. I am here to continue the next slide. The, the challenges and future improvement planned for the machine learning models, particularly in a custom analytic context. Challenges. The KNN needs careful tuning. The KNN needs value of the back performance. Poor selection may be lead to poor accuracy. Decision tree can over overfit without tuning. Decision trees without decision trees may memorize training data, reducing generalizability, maybe bias assumption, assumes all features are independent, which is often unrealistic in a real world data, limited customer data, lack of purchase or behavior history hampers model learning, imbalanced classes, uneven classes distribution may lead to bias models, no deployment. Models are still in the development phase and are not tested in the real world scenarios. Next comes the future improvements. Future improvements are tune models, tune models that is high parameter to incorporate richer customers data to enhance the learning. Try advanced models. Uses models like random forest, SVM, or neural networks better for the accuracy. Balanced data apply technique like smooth to address the classes imbalance. Next is deploy the model. They integrate the model into application via API or cloud. Update regularly. Continuously refresh the model as customer behavior evolves. Thank you.
Everyone, now I'm explaining the code implementation of this project. So let us see. Here we are importing the different types of libraries like import pandas as PD, import numpy as NP, import matplotlib.py plot as PLT, import cbon as SNS. So these are the libraries. Here the pandas are used for loading and handling the data in the table format, that is data frames, and the numpy that is used for the numerical operations, and matplotlib.pyplot which is used to create the graphs of the plots. and Seaborn library, which is a statistical plotting library, which is based on the Matplotlib library, which also gives the better looking plots here. From sklearn.model selection, import train test split. So basically, it splits the data set into the training and the testing sets. From sklearn.preprocessing, import standard scalar label encoder. Here, standard scalar normalizes the numeric data that scales the values in the similar range, and a label encoder that converts the test data into the numbers. And from neighbors import k neighbor classifier. Here it imports the k nearest neighbors model for the classification. From sklearn.tree import decision tree classifier, it imports the decision tree model. From sklearn.neobias import Gaussian NB, it imports the neobias classifier which is suitable for the numeric data, that is Gaussian distribution. From sklearn.metrics, import accuracy score, precision score, recall score, F1 score, and confusion matrix. So these are all are the evaluation matrix which is used to check how good our model is. So here the accuracy score predicts overall correct predictions, and precision score mainly focuses on how many predicted positive values are actually correct, and the recall score focus on the how many actual positives were found in this, and F1 score it is the harmonic mean of the precision and recall, and the confusion matrix which shows the correct and incorrect predictions present in a table. Next is the load the dataset. Now we load the dataset by using the function df is equals to pt.read csv. We have taken the file that is mall customer. We will that will read the mall customer csv file, and that will load into a pandas data frame where we call the function as df. And now we display the first five rows, that is by calling the function df.head, that will display the first five rows of the dataset, so you can get a quick overview of this data. So this is the output of the function, that is it only displays the first five rows of the dataset, as you can see here.
Now I want to explain our next encode categorical variables gender. The next line is the encoder is equal to label encoder. I want to explain that encoder encode the gender column. It is like as we discussed, it is about the male and the female into the numerical values using label encoder. Next, DF reminder that it is considered as the gender. Next, it is about define feature variable cx and define feature variable cx and the target variable. We have I want to define a function to classify the spending score into the categories like low, medium, or high. Next, it is a DF define spending category, or a defined DF is defined that spending score. That is, we will create a new column spending category by applying your function to the spending score column. Next, define spending category. Spending category encodes the new spending category column using the label encoder. Next, Y DF spending category. Here we will assign the target or your target variable Y to the encoded spending category. Next, normalize feature. Scalar, standard scalar, X scaled scalar, that is fit transform. This helps in scaling the features so they have zero mean and unit variance. Next, split dataset. Split dataset into training 80% and testing 20%, while myself explaining about the uh, testing data and the training data. Here we will classify that the here we will trying to classify the training and the testing set. That is training where the data model learns the 80% of the information and the work, and while testing there will be 20% testing. And this is the ratio of 80 by 20. Thank you.
Everyone, I am Arume Sania. I am here to explain the continuation part of the code. The hash train KNN classifier. KNN is equals to KN neighbors classifier bracket open kn underscore neighbors is equals to 5 bracket close. The initializes the k nearest neighbors, that is knn classifier from sklearn dot neighbors. Next is the n underscore neighbors is equals to 5. This is the parameters means the algorithm will consider the at least 5 close training samples when classifying the test sample. KNN dot fit x x underscore train comma y underscore train. The trains the KNN model on the training data x underscore train and the corresponding labels underscore train. Next is y underscore pred underscore knn is equals to knn dot predict x underscore test uses the train model to predict the labels for the test data x underscore test. The prediction are, sto- are stored in y underscore pred underscore knn. Next is the decision tree classifiers. Deci- dt is equals to decision tree classifier, and this initialize the decision tree classifier from sklearn.train dt dot fit x train comma y underscore train. This is the trains the decision trees classify using the training data and the labels. Y underscore pred underscore dt is equals to dt dot predict under x underscore test. This predicts the labels using the trained decision trees and stores them into the y underscore pred dot dt. Next is the Navy bias classifier. NB is equals to Gaussian NB. This initializes the Navy's bias classifying using the Navy Gaussian NB model from the sklearn dot Navy bias. NB dot fit x underscore train comma y underscore train trains the Navy bias model on the training dataset. Y underscore pred underscore nb is equals to nb dot pred x underscore test. This predicts the labels from the for the test and stores the data. Them in y underscore pred underscore nb. Thank you.
This code, this Python code is used to evaluate the performance of different machine learning models using some common evaluation metrics like accuracy, precision, recall, F1 score. There are three models being evaluated. The first one is KNN, K nearest neighbor and decision tree neighbor base. Next, next DEF evaluate model Y test, Y predict, and the model name. This Y test is give the actual value or real label. Y predict, it predict the value by the model, and model name of the model like a KNN, and these are a print below. These are the print statement which helps to print accuracy, precision with weighted average, and recall with weighted average, and F1 score with weighted average. And next, followed by evaluate model y test y predict KNN, and evaluate model y test y predict DT, which followed by KNN decision tree, and evaluate model Y test or Y predict NB, that is Navy base, which is helps to print the or calling the functions evaluate model of a three models Y predict KNN, which predicts the prediction form of KNN model, and Y predict DT. Uh, it helps to prediction form of a decision tree. Y predict NB, it is a prediction form of Navy base. And finally we come across the output of this, come across our output. uh, First, KNN performance. We come across KNN performance. Accuracy is about 0.90, and precision is also 0.90. Recall also 0.90, and F1 score also 0.90. Then decision tree performance. Accuracy is 1, precision is 1, recall is 1, and F1 is 1. F1 score is 1. And then Navy base performance, accuracy is 0.97, and precision is 0.98, and recall is 0.97, and F1 score is 0.98. This is all about output, and above above code for this output. Thank you. Next will be continued by my another team.
I'm going to explain about how we plot the confusion matrix for this. So figure xs is equals to plt dot subplot 1 comma 3 figure size is equals to 15 comma 5. Here this creates a single row of three subplots to hold three confusion matrix, one for each model, and figure size 15 comma 5 sets the size of the entire figure. Models is equals to KNN, YPRED, KNN, decision tree, YPRED, DT, neobias, YPRED, NB. So this is a dictionary that links model names to their predicted values. For AX model name YPRED in zip access model is dot items. This loops through each subplot that is AX, and model result will be stored with the combination of name plus predictions. And CM is equals to confusion matrix Y test Y pred. Here it calculates the confusion matrix between the actual values and the predicted values. CNS dot heat map CM A naught is equals to true, FMT is equals to D, C map is equals to blues, AX is equals to EX. Here it creates a heat map of the confusion matrix using the Seaborn library. A naught is equals to true shows the numbers in each cell. FMT is equals to T, that will format the numbers as integers. CMAP is equals to blues, that will use to color theme. Next is AX set title confusion matrix model name, AX set X label predictor label, AX dot set Y label true label. So these are used to set the titles and the access labels for the each subplots here. PLT dot title layout, PLT dot show. It makes sure that the plots do not overlap with each other and displayed with them. Thank you. So this is the output. This is the output of the confusion matrix. Here you can see that for the KNN, this is KNN model, there is the confusion matrix, and decision tree is the confusion matrix and neo bias. Among all these three, the decision tree will be performed well, and we have taken the references
Where
from Kaggle Learn documentation and Kaggle and the data set from the Kaggle Mall customers. Thank you.